right? Like a CPU, right, stands for Central Processing Unit. So a processor, we talking about, okay, I was waiting for Obakeng. Obakeng is the one who's supposed to run today's class, but I think he is facing some challenges with his laptop. So I just want to start so that we won't waste your data, or at least you're just waiting for someone, or at least we don't know if you'll be able to connect. All right, so this is what we're doing. The hardware components of a computer, right? I'm sure most of you, they know what a CPU is, and you have seen a CPU, right? Anyone who haven't seen a CPU, can you show by raising your virtual hand there? If you haven't seen a CPU in your life, okay, it's fine. Elian there hasn't seen a CPU. Tisetso hasn't seen a CPU. Rose hasn't seen a CPU. Rose, your hand is up. Like, is it because you haven't seen a CPU, or you wanted to say something before? Josias hasn't seen some. Okay, cool. So we see most of you haven't seen a CPU before. So the CPU is the central processing unit, right? The one that we call it sometimes, most of the time, you're going to hear it referred to as the brain of the computer. So all of the processing in your computer, they're conducted, or they're done by the CPU. Last time I told you that the CPU, it is the brain of the computer, and then it is this is where the processing happens. And then also the CPU, what it does is, we said all the mathematical calculations, right, they are performed inside the CPU. The CPU is a component called an ALU, which is the one that performs the calculation. So there are different types of CPUs. So when you're building your PC, or you want to buy a laptop, right, like these are the things that you have to look out for in terms of like the speed. Okay, let me take a call from Obakeng. I think he wants to say something to me. Let me just pause the. Okay, sorry guys, looks like Obakeng is on the wrong link. So let me try to send him the correct link. I think there are 2 or 4 people also on this wrong meeting. So let me just forward the one that we're using now so that they can join us. So we have like maybe half of the people joining on a different link. Where is the link so I can forward it to Solom's to Obakeng link? All right, I've sent him the link, so we're just going to wait for him to join. Okay, so as I was saying, the CPU, it is the central processing of the central processing unit of the computer. So all of the processing happens inside, or is done by the CPU, right? And then there are different types of CPU. Sometimes we hear that we have a single core, we have a multi-core. This is just like a term saying, okay, it's a core, there's a CPU that is only one CPU, and then we have the multi-core, which is like the different many cores inside the CPU. So what's the difference with that? And then how does it help you when the CPU is multi-core? So it increases when the CPU it's a multi-core, it increases the capacity of or the instructions that CPU can handle at a time. Unlike when you're having a single core, it can handle a limited number of instructions. But when your CPU now comes in as a multi-core, that means it can handle more than what a single core can handle, right? So that now the multi-core, it shares the load amongst the cores that it has, right? So if it is let's say if it's a dual core, so a CPU that has 2 cores in it, we call it a dual core, right? And sometimes we hear like a quad core that is 4 and then different numbers, right? So they come in with different numbers. So if your CPU is a multi-core, that means it can handle more instructions than what a single core can handle. So we have different types of CPUs, right? And then we're going to look at the virtual technology, the hyper-threading, the speeds, the overclocking. So when you're buying a PC, or like when you're buying a PC or building your own PC, these are the things that you have to look out for first and saying, okay, like look first, you look at the type of job that you're going to do, right? Let's say you are going to do admin, like data capturing. You don't need a CPU that is like the higher processing power. You just need like a normal CPU. An Intel Celeron with 4 gig of RAM will work. So the size or the type of CPU that you're using, it will also determine the speed, the processing speed, or also how it processes the instructions in your machine. So let's say now you're a developer or you are someone else who deals with softwares or programs that require more RAM or require more CPU speed. So you're gonna go for CPUs that have higher processing capacity. For example, we have like the Core i7, the Core i5, the Core i3s. So for a developer, most of the times, if you're a developer, you want to go for CPUs that have the higher processing speed or higher processing power. For example, the Core i7s and then the higher speeds. So those are the ones that you're going to go for if you are a developer, right? But for someone else, let's say now you're a technician, right? And then they ask you to build a PC for someone who's doing data capturing. That person, what they're only doing is they are maybe capturing information about the users, or just using Excel or PowerPoint or these softwares that don't really require the much of the processing power or the higher speed of processing, right? So when you're building a PC or choosing a CPU, it will also be dependent on what type of work that person is going to be doing. You can see now we have a Core i9, of which these are the type of processors that have like the higher processing power or higher processing speeds. They usually come with as a multi-core. We said a multi-core, it means that this CPU has more than one core inside it, right? Of which it provides this CPU with higher capabilities in terms of like responding to requests that the user is dealing with every day. All right. So central processing unit, it looks like this, right? This is a CPU. This is a Core i9 owned by Intel. So when it comes to CPUs, we have like two big companies, two major companies that are producing CPUs, right? We have the Intel and then we have AMD. So the Apple products or the Apple company, most of their devices, they use the AMD CPUs. So these Intel and then the AMD, these are companies that produce or manufacture CPUs. So you're gonna find a CPU coming from the Intel and then the CPUs coming from the AMD. It's not that these are not only the two that are manufacturing CPUs, but it's just that they are the ones that are kind of dominating the industry right now in terms of like manufacturing these CPUs. So central processing unit, we said, can be referred to as the processor. So you're going to hear people saying a processor. They're talking about the CPU, right? When they say a processor, it's the CPU, right? And then microprocessor, they're talking about the CPU. So that's the same term. So as I said, one thing that we have to take out from this slide is that we have two major companies or big companies that manufacture the CPUs, right? We have the Intel and then also we have the AMD, which are two big companies that manufacture CPUs. And then the other thing that I've said is that the CPU, it is the brain of the computer, right? It's the one that processes anything that you're working on your PC. It goes to the CPU and the CPU processes that and then gives some of the work maybe to the RAM or maybe to hard drive to store it or maybe to the cache. So, but it is the processor, it is the brain of the computer. All of the processing, it happens inside the CPU of your computer. And then the other thing that I said was, if you're building your PC and then you want your PC to have like the highest speeds, right? You want like you're building a PC for someone else who told you that, okay, they want a PC for graphic designing. You want a PC for web development or for development, right? So when you're building a PC, it will be dependent on the requirements of the user. So you will build a PC based on the requirements of the user. So we said, okay, if the person is a graphic designer, we note, okay, they will require a CPU that will really process the graphic, quickly process the graphics. And Intel Celeron won't do for that type of job, right? So you have to go for the CPU that has the higher capacity or higher processing power so that it can meet the requirements or the needs of this user, right? So these are the things that you have to put in mind when you're building a PC. When anyone comes to you and say, okay, since you're a technician, since you're a system support technician, you're working as a technician, these are the things that are, my requirements. I want to build a PC that will do 1, 2, 3. So you look at the requirements coming from the user, And then what you do is you say, okay, since you want to do data capturing, so data capturing, it doesn't require more RAM, right? It doesn't require maybe much higher processing CPUs. So what you can do is say, okay, for you, you can go for a standard PC, and then also look at the budget of the user. Most of the time when the users come to you, they will tell you, okay, they want a PC, and then they'll tell you their budget, right? So based on the budget and the requirements, then you will decide, okay, which type of CPU are you going to buy for them, or which type of laptop are you going to buy for them based on the requirements and also on the budget. If you are on a work environment, most of the times we're not buying anything. The company tells us what exactly we want to do. Okay, Opakeng, you are online, right? Opakeng, can you hear me? I see the IT training email address or user is online. Opakeng, are you the one using that? I think Opakeng's his mic is off. Okay, who logged in as IT training? Because today's class is for Opakeng. I don't want to take that class from him. IT training. I don't know who that person is. I'm not sure if Opakeng can hear me. Let me just call him and find out if he can hear me. All right, as I was saying that when we are buying or building a PC, right, these are the things that we have to put in mind. The first, yesterday we said the first thing that you're going to buy, is it yesterday or the day before? Opakeng, are you connected? Are you?
I'm connected, but my system is to be loading right now. I can hear you, but I can see nothing on the TV. Okay, I'm coming now.
Okay, and then also you have to unmute your mic there. I think you're muted. All right, you will tell me when you are ready, right? Just raise your hand when you are ready, when your system is ready, right? So, okay. All right, as I was saying, right, guys, that the system, when you're building your system, you have to look for a proper or a good processor or microprocessor or a CPU that will meet the needs of the user. As I said, that when you are in a work, in any organization, what happens is we're saying the user will tell us, okay, there's someone logging in. Okay, let me do this. All right, so that's the CPU, right? Okay, let me move to the next slide. So the CPU, you see the CPUs at the top there. We have the BIOS there, we have the video, we have the RAM, video, talking about the graphics, right? And then the HDD, this is the hard drive where you permanently store your information, right? So that we said an HDD is a non-volatile storage device, right? Which means that when you switch off your when you switch off your computer, it retains the information that was stored on your hard drive. I'm sure you also the USB is a non-volatile device or non-volatile non-volatile device, right? When you load maybe let's say movies on your CPU, right? No, sorry, on you load movies on your USB, what happens is that that information that is stored on the on the USB, when you pull out the USB from your computer and then you put it back after some hour, then that information is retained, right? So that means that is a non-volatile storage device. It can retain data even though after it has been switched off, right? And then we also have like the SSD, right? Okay, IT training is in. Opakeng, sorry man, you can take over now.
Okay, Mr. Melusi. So you have you covered everything, or I can start from the beginning of my presentation? Mr. Moyo. Mr. Moyo.
So what you can do is you can start wherever you start. You prepared, right? Like you start from the beginning, but whatever you prepared, start from there.
Okay, no stress.
Okay.
Let me just share my screen now. Okay, so what I will do is start from the introduction exactly where I started, and touch on the things that Nkosinathi touched on Monday, just to polish a few things there, and I will continue from there. Just waiting for my system to share the screen. Okay, can you see my screen now?
Yes.
Yeah, we can.
Yes.
Okay. So how I prepared this was like I did not include any pictures because I was gonna use the internet for us to see pictures while we're discussing it. Okay. So welcome guys. So here I am, at least finally. Welcome to the introduction of PC hardware, software, and troubleshooting. So what is a computer, guys, if you were to say computer? The term computer is derived from a word compute, which means to calculate. So basically, we can say generally a computer is something that does calculation. But coming back to this term, they say computer is basically a group of electronic devices that can accept data, conduct a series of arithmetic and logical operation on it, and give results of the operation as information that is useful to the people. So what they're basically saying is that a computer is an electronic device that takes information, calculates it, or does whatever it's supposed to do, and brings the output. So that will be the introduction of computer. What is a computer? So on Monday, we touched on what is a case, and we said a case is a form factor that we use to hold the hardware of the computer. So the case is the form factor, which is all we see at our workplaces. Because Nati said they come in different forms, whereby we have the desktop and the tower. Some of them, they are straight. Some of them, they are horizontal. So let's just go into Google and check different form factors of PC. Hope my internet will do me good today. Okay, so coming back to computers, we know we have different form factors of computers. So depending on your preferences of a computer, you might have this small form factors or the bigger one, depending on what you will be doing with the PCs. Because now the bigger the case, that means you will need more hard drives. You might include more external hard drives there, or I mean internal hard drives, or some cooling stations there. So this is the types of form factors here in this picture here. Okay, my network seems to be slow, but I believe you can see this case here. These are the different types of form factors. And also we have ones like this that lay horizontally on the table, okay? So those are the different types of cases. Coming to types of system boards. Nkosinathi touched on different types of them, which it is the ATX and the ATX, as he showed last week, or I mean Monday, it's not last week. Okay, my system seems to be responding very slow, guys. Sorry about that. Okay, let me just do this. So yeah, we touched on the different types of system board. These are the ones that Nkosinathi talked about, the AT, the ATX. And also depending on the user's preferences, you will decide on which ones you need. Okay. Okay, I'm trying to move here, but it seems like my system is stuck. Can you hear me, Mr. Melusi?
Yes, I can hear you 100%. Yes.
Okay, it's just my screen is stuck right now.
I think it's going to be slowed down by, is it Chrome? I'm sure. Do you open
Yeah.
Chrome?
Yeah, I'm using Chrome at the moment.
Yeah, Chrome will slow it down, yeah. Which one is it? Like, is it those the 2 gig ones, the 2 gig PC?
Yeah, it's those ones.
Oh yeah, yeah. Chrome will slow it down.
We'll slow it down. Can I use a different browser?
Yeah, try that to use a different browser. Yeah, if you anytime you want to use a browser, try to use a different browser.
Yeah, I do have a different browser right here.
Yeah.
Should be opening with Microsoft Edge right now. Okay, well, Edge. Okay, I don't know why. I think the Teams application is also making it slow because usually it is slow, but not this slow.
Yeah, must be the applications that are running now. I'm not sure. Are you able to accept people to the meeting? There's someone wants to on the lobby. Do you see the
On the
people on the
lobby.
lobby?
Yeah, I've been seeing people there.
Can you admit them?
Okay, yeah.
Because I have class now, another class that I wanna starting now.
This piece is not doing me any grace.
Yeah, you need a better PC now. Okay, let me do this. Shucks, let me quickly do this. See if I can. Tararararararam. What do I want to do now? I just want to, let's say, share that. All right. All right, guys. You will tell me when your screen is back on, right?
Okay.
All right.
Thanks.
So guys, we're looking at CPU. I think today we're gonna knock off at 1, right? Oh, it's almost 1. Shucks. Okay. So let's look at the CPUs, right? Lane grid array. So we have different types of CPUs, right? when your CPU is called a LAN grid array, or when your motherboard is a LAN grid array, that means that the socket. So we have two things, right? We have the CPU. So this is your CPU, right? And then down here, okay, I have to admit someone else. Okay, to the group. Okay, so this is the socket. We have two things when it comes to CPUs, right? We have the socket. The socket is what you find inside the motherboard, right? The socket is where we place or plug in the CPU. So this is your CPU, and then this is the socket. So when we say a CPU is a LAN grid array, that means you find that the socket has the pins that are protruding out. It has the pins, and then the CPU on its own at the back, it has like the metal contacts. So these contacts that we have at the back of the CPU are the ones that we attach them to this CPU. But the most important part is this part. Okay, I forgot that when my arrow, you can't see my arrow, right? All right, so this you can see the socket is the one that is brown, right, with the protruding metals, right, that are coming out, and then the CPU socket is the one on the side. I don't know. I used to have a software that allowed me to draw on this. Can I draw? Okay, I can't draw. Okay, there's a software that I'm supposed to download, and then so that I'll be able to draw on the screen, right? So CPU LAN grid array, right? I'm sure all of you can see. So this is the socket. The CPU, when we're saying that if a socket is a LAN grid array or LGA socket, it means that it has the pins that are protruding, right? And then the CPU on its own, at the back of the CPU, it has metal contacts, the ones that we attach to the pins that are protruding from the socket. So we have two things. The motherboard is the one that is the socket, right? The socket is just a location or a place where we plug in our CPU. And then the CPU at the back, we're saying it has the metals. There are some CPUs that have the holes behind at the back of the CPU, right? But now we're looking at the LGA. So most of the times when you hear that a CPU or a socket is a LAN grid array, it means most of Intel is the one that uses or manufacture CPUs or sockets that are LGA. And then when it comes to AMD, they always prefer or they go for sockets that we call them the pin grid array. So this is the socket which we call it a LAN grid array. Let me see if we have another one on the side. So okay, you can see now the CPU, which is a pin grid array. Now the socket, which is the white one right on the side, you can see the socket is the one that has the holes. Now, right, we call it a pin grid array. So the socket has the holes, and then the CPU now on its own is the one that has the metals that is like the small metals that are protruding from the CPU. Those are the ones that we plug in on the socket of the CPU. So let me just quickly go back a bit. Go back to my previous slide. So you can see the difference now. On this side, we have the LAN grid array. So the LAN grid array, we said the CPU, at the back of the CPU, it has the metal contacts, right? And then the socket is the one that has the metals that are protruding out. Then we take the CPU and then put them on the CPU socket and then apply or lock that CPU. So that's the difference between the pin grid array and then the LAN grid array. The LAN grid array is the socket that has the pins that are protruding out. And then the CPU on its own, it has like the metal contacts. And then when we come to the pin grid array, the CPU is the one that has the pins that are protruding out, right? And then the CPU socket is, as you can see, it's written on the white CPU, there's written socket AM4. Which is for AMD, right? Type 4. So you can see now the AMDs or the socket now, the pin grid array socket is the one that is the holes, and then the CPU is the one that is the contacts. So that is the pins that are protruding from the CPU, and then those pins, that CPU, we position or we plug it in to that socket. So that's the difference between these two. So now what it means is that, let's say you are buying a CPU, we have to check your socket on the motherboard. What is it, right? Is it a pin grid array socket or is it a LAN grid array socket? So now if I buy a CPU that has the pin, that has the metal contacts at the back, and then try to plug it into this CPU socket, it won't work there because I got the wrong CPU. So you have to check first the socket on your motherboard. What type of socket is it using? right? So we have two types. When buying a CPU, we said last time I told you guys that when building your own PC, the first thing that I usually buy myself, I'd advise people to buy the motherboard, and then the motherboard will tell you what type of CPU, what type of RAM are you going to buy, things like that. So now, when your CPU, you check your CPU, what type of CPU socket is it? Is it a LAN grid array? If it's a LAN grid array, then you buy the CPU this type. If it's what you call a pin grid array, then you go for this type. I'm not sure if it makes sense. Anyone who understands what I'm talking about or understand my explanation there. So we said we have two, the LAN grid array, and then the other things that the other part that we broke down is the difference between, we have a socket and then we have a CPU. So the socket, we're saying this is the location or just the place where you plug in your CPU, right? And then we're saying now we have two different types of sockets. We have the LAN grid array and then we have the pin grid array. Those are two different types of software sockets. And then we're saying now the other point is that the LAN grid array, most of the times it is used by a company called Intel, right? We looked at the two companies that manufacture these CPUs. And then point number two was that the second one is the pin grid array, which is mostly preferred by the AMD company. Most of their sockets, they are pin grid array. And then we said the pin grid array, the socket has the holes, right? And then the CPU is the one that has the pins that are protruding out of the CPU that allows you to plug them into the socket that has the holes. I'm not sure if we understand that part. Josias, do you understand that part, the difference between the LAN grid array and then the PGA? So the terms, you're going to
Yes,
hear people calling them the LGA, and then some will say the PGA. You got it, Josias?
yes, I've got it, Melus.
All right. So that's it, right? Like we have the LGA and then we have the PGA. Those are the two. So what I'm saying is, before you buy any CPU, you have to check first your socket. It's the same with when you're buying a RAM. You have to check your motherboard. All the motherboards that you buy, especially the newer ones, they are written down next to the socket. It will be written what type of socket or what type of CPU are you going to plug there, and then it will be written what type of socket is it. They will write LGA next to the socket, or they'll write PGA next to the socket, and then they will tell you, okay, what type of CPUs you can plug in there. And then also when it comes to the RAM also, the socket on the motherboard, it will be labeled on the side that it takes only DDR3, it takes only DDR4, it takes only those type of things, right? So basically, that's the concept between these two. So before you buy any CPU, you have to check your socket. What type of CPU does it take? What type of socket is it? Is it an LGA or a PGA, right? So that you don't buy the wrong CPU. So we have two things, the socket and the CPU. All right. So you can see now we have the CPU, the AMD, and then we also have the Intel. So basically now this slide, what it does is comparing the two. Is it interchangeable or is it not? Most of the time, the reason why it's not interchangeable, you find that is because of the socket, right? You find that the socket that's in there is a PGA, and then maybe the Intel prefers the LGA types of CPUs or types of sockets, so it might not be interchangeable. But if it fits, then why not plug it there? Unless if it gives you any problem, I don't see any problem with that if it fits in there. So this is the AMD, and then this is the Intel. So we're going to be CompTIA, when you're writing a CompTIA exam, they're going to be looking at these that you compare. They'll be comparing the two, the AMD and then the Intel. We said these are not the only companies that manufacture CPUs. It's just that these are the ones that are dominating the industry now. All right. And then the socket types, AMD. So the socket types, basically, we say the socket, this is just like a position or a location where we place our CPU. So those sockets, they have different types. So again, in the motherboard or on that motherboard, it will be labeled that the socket type is a AMD, and then what type is it under AMD? STR4 or AM4, AM3 plus, AM3, AM2 plus. So the CPUs, even though the CPU is an AMD CPU, it might only be, you might only be able to plug it only on what, maybe on an AM4. You find that it doesn't fit on an AM3 plus. So you have to check, okay, if you are buying a CPU, first thing that you check is the CPU socket on your motherboard. And then it will be written on the side AM4 socket type. And then when you go to buy a CPU, you will check, okay, this CPU, is it for AM4 socket or it's AM3 plus socket. It might be a AMD CPU, but now check what socket does it fit into, right? So these socket types, AMD has all of these, the FM2 plus. So the difference will be maybe just you find that the pins, maybe the AM4, it has maybe, let's say 100, it's just an example, right? It's just that maybe, let's say AM4 has maybe 100 pins or 100 slots inside the socket. And then you find that maybe your CPU has 150. So you find that your CPU can't fit on AM4, but only fits on what? On an AM3 plus. So you have to check. Again, we said building your own PC, you check the motherboard will be labeled that the socket is an AM4. And then when you go to buy a CPU, you will note, okay, this type of CPU can only be plugged in an AM4 or AM3 plus socket on the motherboard, right? So these are the sockets for AMD type. And then the Intel, on the Intel side, we have the LGA 2066, LGA 2011, LGA 3066. So they are different. These are different socket types, right? These are sockets for. These are sockets. So if you're taking your A plus, these are the things that you need to know, right? The types of AMD sockets, and then the Intel socket types. So the questions that you're going to see when you're writing an A plus exam is they will write down all of these sockets, maybe two from AMD and then maybe two from Intel, and then they'll ask you which one is the socket for Intel and then which ones are the socket for AMD. Again, I told you that you can see this side is written LGA 1366. So Intel prefers that their socket types to be what? A land grid array. So most of their sockets is LGA. So anytime you see LGA 1366 in an exam, just know that it is part of the Intel sockets. And then the AM, they keep on changing, but their CPUs or their sockets is pin grid array. So these are the socket types. So most motherboards, they have different types of CPU sockets. So just check the labeling on the motherboard and then you will note, okay, what this socket is for what exactly. All right, CPU package, we have AMD Ryzen Threadripper, package specification, socket type, okay, of number of threads. Okay, we're gonna break it down, this one, the number of threads, and then the L1 cache, what does that mean? The package STR4. Okay, the CPU top view with integrated heat spreader. So some they come in with the integrated heat spreader. So the CPU sometimes it can overheat. Like so once a CPU overheats, you will see that your PC will start to have like intermittent shutdowns, right? It keeps on switching on and switching off. It is because there's overheating on your machine. And then, but some of them these days they come in with integrated heating spreader. The reason why you're going to experience overheating, it is because maybe the air circulation on the CPU, the air circulation on the case is not enough to circulate to take the hot air from the CPU or from the casing outside of the PC, the CPU or the processor, outside the box, I mean, and then bring in the cooler air. So you just have to check, okay, how is your cooling system, right? And then the other thing that might affect you in terms of like overheating on your machine is because some people, like especially the gamers, right? You find that they play games, let's say maybe from morning, maybe till like 4 or 5 non-stop, right? And then their cooling system is not good enough to cool down the CPU, and then they start experiencing the intermittent shutdowns whereby the system switches off and switches on. So if the cooling system on your machine is not adequate enough, it's not bringing in enough cool air, it will affect the system, and then you see that your machine now will start experiencing what we call intermittent shutdowns, whereby it just switches off and on without even you knowing, okay, what's happening. But the main reason will be because of the overheating, which is caused by not enough cooling power or system in your machine. But most of them these days, as I say, they come in with integrated heat spreader. So this is the top view of the CPU. And then the die, this is the part that has to contact or go straight to the motherboard. And then this is what happens, or this is where the cores are. Top view with integrated heat spreader removed showing die. This is the top view. Lane grid array LGA side showing contacts. So you can see this is the LGA. So it has the metal contacts. This is the ones that we apply to the pins that are protruding from the motherboard if it's an LGA. We said the socket of the LGA, the socket is the one that is the pins that are protruding, and then the CPU on its own, it has the metal contacts which we have to attach them to the pins that are protruding from the CPU socket. So basically this is the CPU, this is the top. So if there is not enough cooling system in your CPU, in your case, it can cause the CPU, it can burn your CPU. Your CPU can be fried by that part if there's not enough cooling on the machine. All right, this is the die map or the CPU on the side, right? So we have the processor graphics. So some of the CPU, they come in with their own graphics, right, processing, right? So in terms of like the graphic processing, they are built in on the CPU. And then we spoke about the multi-core, right? We said we have a dual core, we have a quad core. So this one is a quad core CPU. You can see that it is 1, 2, 3, 4. What does that mean when a CPU it's a quad core? We said if it's a quad core, now it can handle more instructions than what a dual core can handle. So now the load can be distributed equally to all of these cores. So which means it makes your CPU or it makes your CPU your system to be faster because the load that goes to the CPU is shared equally to all of the 4 cores that you have in your machine. For example, we said this type of CPUs or this type of machines, we make sure that we build this type of, we give these machines to people that are dealing with maybe graphic designing or someone who's doing development or anyone who's running systems or programs that require higher processing power. Then we need maybe to buy them a dual core machines, right? So now we have what we call L3 cache, which is shared among all of these. So we said a CPU, it is the brain of the computer, right? All of the processing, it happens inside the computer. So everything that you're doing on your computer, it goes to the CPU, and then the CPU processes that, and then there are other devices that output the results and stuff like that. So anything that you're doing, can you imagine now if you've opened maybe 3, 4, 15 programs, how many applications do you usually open in Chrome? Let's talk about that. On a daily basis, minimum, how many applications do you open in Chrome? CN. On Chrome, let's say you're working on Chrome, how many applications do you usually open?
5.
5, that's minimum, right? And then, Kiriboni, how many do you open usually? Like how many web pages? Let's say you're working on Chrome, how many websites or how many web pages do you open when you're using Chrome? How many pages are opened on Chrome? Rose.
Sir?
How many applications or programs do you usually open when you're working on your computer?
Many. Maybe somewhere 8.
Right? 8, right? So you see, like most of the time, most people, what they do when they're working on a PC, you find that there are like maybe 10, 15 programs that are opened, and then on Chrome there are like maybe 5, 6, 10 website or web pages that are opened. So all of that, it goes to the CPU. So the CPU, as I said, it is the brain of the computer. Remember yesterday we spoke, is it day before yesterday, we spoke about a chip called the South Bridge. And then we said the South Bridge, it handles the communication that are coming from the slower devices. Like, for example, USB communicates directly with the South Bridge. We said the hard drive communicates directly with the South Bridge. And then that information goes to the South Bridge. The South Bridge takes the information to a chip called the North Bridge. And then we said the North Bridge now takes that to the CPU. So if your CPU has 4 cores, what happens is we have something called the L1 and the L2 cache. So for example, what does that mean? The L1 and the L2 cache, it is a temporary storage that is assigned to each core. So let's say now, for example, the good example would be you now as human beings, right? if I throw two balls to you, right? Let's say like a soccer ball, right? I throw them to you, like you'll be able to handle or hold two of them, right? But what if now I throw 10 at a time to you? Will you be able to hold 10 soccer balls at the same time?
No.
Right? It
No.
becomes difficult as humans, right? It becomes difficult for us. So it's the same thing with these processors, right? Let's look at this this way. If this CPU had a single core, right? So every time when Rose, Kidibone, or CN is working on their PC, they've opened like maybe 10 to 15 programs. All of those programs, they require the attention of the CPU or the core, right? It has to respond to their request. So what happens is the core, if it has too much request, right? If it has too much instructions, requests coming from the different applications, what it does is it stores some of the instructions on something called the L1 cache. The L1 cache, it is a temporary storage, right? It is for temp storage. The CPU will store the data, some of the instructions or some of the requests on the L1 cache. So just for easy access, the L1 cache, it is fast, but it doesn't have bigger storage, so it won't be able to handle maybe all of the information that the CPU want to store. So let's say the CPU has 10 instructions, right, that is working on, but it says, okay, sorry, I can only process 2 right now. So the rest, the 8, I want to store them what on the L1 cache, so that once I'm done with these 2, once I'm done processing the 2, I can quickly move to the ones that are on L1, because the L1 cache, we're saying it is built inside this core. If this is the design, right, the L1 cache is built inside the core, so it will store other instructions on the L1 cache. And then we say the L1 cache is not big enough. So L1 cache is just a storage, right? It's similar to RAM, but it is the RAM that is faster than the actual RAM. So it just was temporary storage. So it says, okay, I can process 2 now. That's just an example. I can only process 2 now. So the rest, the 8, I want to store it on the L1 cache. But we say the L1 cache, it is fast, yes, but it doesn't have enough storage, enough space to store all of the information. So you find out that it can't maybe store all of the 8 instructions. So this PC, if you see any CPU having an L3 cache, just know that inside of it, it has L1 and L2 cache, just for temporary storage, so that the CPU will quickly address or quickly attend to that other request. So we have the core. We said inside this core, there must be an L1. L1 cache, the CPU was processing 10, but it said, okay, I can't process 10, all of them at the same time. I need to store 8 somewhere. Where does it store that? It stores it on L1 cache. But L1 cache is not enough. If it's not enough for storing all those 8 other instructions, it moves to L2 cache. L2 cache is also built in the core, right? And then if L1 and L2 is full now, that information, the other instructions will be moved to what? To the L3 cache. So now we're giving you an example of, let's say it's only one cache, one core, right? Forget about these ones for now. So it will store that on the L3 cache. So if the L3 cache, it happens sometimes that we open a lot of applications and then a lot of programs, and then we overload our CPU. Then the CPU will say, okay, sorry, now I don't have space on the shared L3 cache, and then some of the information will move to RAM, right? RAM, most of the time, if you find that, for example, now we had Obakeng trying to present, right? But now his CPU and the RAM, it wasn't able to handle the request or the request that is coming from the applications that he opened. He opened Teams, he opened Chrome, and then he was also presenting, of which now he opened another application there. So his PC wasn't able to handle all of those instructions. So if the instruction if L3 cache is full, then it goes to RAM. It happens sometimes that your machine now, the L3 cache is full, right? Is full, and then the RAM also is full now. So if L3 cache is full, the CPU, it moves some of the information to the RAM. And then if RAM is full now, all of those, now that means now the RAM or the CPU has ran out of temporary storage. What happens is it moves some of the data, it borrows space from the hard drive. We have what we call the virtual memory. That virtual memory, it is borrowed by the hard drive, borrowing your CPU. Your CPU will say, okay, I don't have space. Then it borrows from the hard drive. We call it virtual memory. And then that virtual memory is usually double the size of your actual RAM. So if your RAM is 2 gig, that means your CPU by default, it is going to borrow you 4 gig of RAM, of which you can manually change that on your RAM. So by default, it is going to give you double the size of your actual RAM. We're saying now your actual RAM, sometimes it usually, let's say if it's 2 gig of RAM, then the hard drive will borrow you what? A 4 gig. So I'm sure most of you have seen whereby, okay, we have a good example of Obakeng's PC, right? It failed totally. So that means that now that PC, he has tried to borrow space from the hard drive, but now also the hard drive is like, it's not in the space, is not enough. And then in the end, you will start to see your PC not responding. You try to open any application, the PC is not responding at all, right? Because now the CPU, it has so many instructions that it's trying to process, but now it is blocked or it is choked because there's no space or to store any of that information. Now is you'll see a scrolling wheel. We call it a scrolling wheel. That means now your CPU doesn't have space at all. Now your machine will start to freeze or start to all the applications won't be able to respond. But how do we fix that problem? When there's a scrolling wheel and then some of the applications are not opening, how do we fix that? How do you usually fix that? You are working on your PC and then you start to see a scrolling wheel. You try to click somewhere, it's not responding. How do you usually fix that? Spamant,
Yeah,
how do you fix that?
I was struggling to get in the meeting today. Now, I started now to join the meeting. I don't know this one.
All right, Kedibon,
What? Okay.
okay, I'm
Can I
coming
take
just to you just now, right? Kedibon. Kedibon, your mic is on mute.
Can you hear me now?
Yeah.
Yes, I'm saying that usually when my PC cannot process all the applications at the same time, I usually can probably buy a memory card. Yeah.
So you buy a new memory card so to increase the RAM space, right?
Yes.
Okay.
That's what I can do. Yes.
Okay. Obakeng, you want to take over or you want to answer? Is your PC fine now?
No, my PC is not fine. I just wanted to answer.
All right, sharp. Yeah.
Yeah.
What
So
do you usually do?
most of the time, if a computer is not responding at the time, you can kill the process or task manager.
Right. That's
and
the
process it.
yeah. That's the other. So Kidbone, let's say you are at work, right? You are okay. Sandile, I wanted to say something before Sandile, how do you fix it?
Nah, I wanted to say the same thing that
The same thing.
Obakeng. I wanted to say the same thing that Obakeng said.
All right. So, Kidibone, the first thing that we usually do, right, if the PC is not responding, you're going to get this a lot whereby in a work environment, people will call you and say, okay, my PC is not responding. I can't do anything. I can't open any application, right? So we have a task manager on our computers. That will be the shortest way before even move to buying a PC, buying a RAM, right? So the first thing is, yes, the first thing will be you have to go to task manager and then try to kill any application that is not responding, right? If that is not helping at all, usually we have to restart the machine. When you restart the machine, that means you are releasing memory or you are releasing instructions that was inside the CPU. Now the CPU or the computer starts afresh, then it can work properly after that, right? So the first step we're saying it is going to task manager and then kill programs maybe one by one, or looking for the program that is not responding and then try to kill that specific program so that the PC can go back to normal, right? And then if that is not working, because sometimes it happens that, okay, you try that and then it's not working. So the second step will be restarting your machine. When you restart your machine, you are clearing the process, you're clearing, because we said RAM is a temporary storage, right? And then this L1 cache and then the L2, they also are temp storage. So once we clear that, once we switch off our machine, we are actually refreshing the RAM, we're refreshing the the L1 cache. So this system now will start afresh with a clean slate, whereby it doesn't have any processes that are running. And then you'll see now your PC will go back to normal. So the first step, what you do is first make sure that you kill the programs that are not responding. If that is not working at all, that's when you can move to number 2, whereby you're saying, okay, let's do what? Let's restart the machine. Restart the machine. If it keeps on doing that, let's say you get called by the same user every day for the same thing, then that means now we have to go to Kidiboni's plan, right? Whereby maybe we increase the RAM, because that means that person, the work that you're dealing with, it requires more RAM than what he's currently using at that moment. Then we can upgrade now, right? Does that make sense?
Yeah, thank you.
All right, so we're saying the first step will be task manager. Number 2 will be restarting the machine. And then we're saying, okay, if this thing keeps on reoccurring, you checked, okay, you're getting called by the same person for the same problem time and again, that means we need to come up with a permanent solution, which is maybe upgrading their PC. Okay. All right, then the processor graphics. And then we said here we have the core. These are cores, right? So if we have 4 cores like this, right, in your machine, that means each core, it has its own inbuilt L1 and L2 cache. This one has its own inbuilt L1 and L2 cache there, and then they are all sharing what? The L3 cache. So it means that if core number one is full now, there's no space in core number 1, it moves the data to L1 cache and then moves the other data to L2 cache. And then if its L1, L2 cache is full, it moves it to the shared L3 cache. So the shared L3 cache, it is shared amongst all of those 4 cores that we have. So, but all of them, they have L1 and L2 cache built inside of them. I think this is the inside of the CPU. This is what happens inside the CPU, right? All right, this is the die map. Okay, let me move to the next one. So if you want to check your CPU speed, the performance speed, where do we check that? You want to find out if you're overloading your PC. Where do we find that information using when you're using a PC? You want to find out how much space, how much processes, the percentage of the processes that the CPU is running on, the percentage of the RAM on your machine. Where do we go to find out that information on our machine? Anyone wants to try? Where do you find that information? You want to check if you are overloading your machine. Where do we go to for that type of information?
Well,
anyone wants to try? Opake, you wanted to say something?
yeah.
Yeah.
Can you hear me?
Yeah, I can hear you.
Yeah, I said on Task Manager, there's also a tab on that's called performance. It also shows like the memory, the disk, and the processes that the CPU utilizes.
All right. Yes.
On Task Manager, yeah.
Correct. So on Task Manager, like Task Manager must be your friend when you become a technician, right? Like this is the place where you have to go to most of the times to check, okay, you want to kill a program, you want to see processes that are running on the background, you want to change something. So Task Manager, you have to go in there and check what's happening on Task Manager, right? There's so much information on Task Manager. Okay, let me try maybe to share my Task Manager and see if I'll be able to show you. So what's the shortcut to get to Task Manager?
You can right click on your you right click on the status bar, then it will give you the option of Task Manager. Then you click on it.
Right. And then the other shortcut is Control-Shift-Escape, right? It will take you directly to Task Manager. Okay, let me try to switch my screen here so that you can see what exactly we're talking about. And then on your PC, if you don't know where to find this, on your PC, if you're using Windows 10, just type in on search there, type in Task Manager. All right, let me try to. Where is task manager? I'm not sure. Can you see my task manager, guys? It's written task manager at the top there. Can you see that?
Yes, it's visible.
Yes.
All right, so you can see processes, right? So these are the applications that are running on the background, right? So they keep on running on my background, and then it can also show you how much RAM, how much memory, how much CPU each application is taking. You can see Microsoft Teams, how much CPU is it taking, right? It is a big application, which I think is the one that was kind of slowing down Opakeng's PC, right? And then also, where's the other one? Okay, on my side, on Chrome, I didn't open many application. There's only maybe one web page that is opened. So you can see the ones that are using much of your space. And then memory, which one is taking more memory? You can see how much memory Chrome takes there, right? It takes so much. I only opened maybe one or two applications there, but this is the amount of memory that it takes. And then the other one, can see Teams, it is the one that is chows a lot of memory. And then I open my Visual Studio Code, that's the amount of memory that is taking. And then you can also check the disk, how much each application is taking on your disk. Right? And then the network, which one is using network right now, which application? Microsoft Teams is using network. It's the only one that is using my network right now. Right? And then is there anyone that is showing my graphic processing unit? There's 0 3D, there's nothing on the engine, nothing. And then power usage, you can see which application is taking more power from your machine, right? So background processes, these are the applications that are running that make your Windows 10 to run, right? Most of them, you don't have to stop them, right? Because okay, if you want to stop any application, let's say I want to stop Explorer, right? Here it is, I highlight it, and then I want to restart it there, I can restart it there. But this part, the background processes, these are the processes that your Windows 10 relies on. You can see it is about 179 processes, and then all of those processes are already taking some of my memory, are taking some of my CPU space. They're already taking that. If you want to restart that, you can highlight it and then restart that particular application. And then if I want to stop or end any task here, I just highlight that, and then let me say I want to end Excel, right? You just click on it and then you end the task there. Let's say Excel is the one that wasn't responding. So you can see I have ended that task. So you're forcing a task to close when you come to Task Manager here. And then performance, you can see if I want to focus on disk, I can see how much disk is taken from a machine. There's a percentage there. And then memory, you can see how much memory is being taken from a CPU. And then you can see available is 5.9. You can see in use compressed, and then speed is 2.4 megahertz. And then form factor. So we're going to talk about the different types of what you call these, the RAMs, right? Different types of RAM. We have the form factor, the sodium, and then we have the DIMM. And then we're going to break it down. What does that mean? The sodium and then the DIMM. And then Wi-Fi, you can see I'm using much of my RAM, how much, and then the SSID that I'm connected to, you can see also 5G. Connection type is 802.11ac. IP, there is my IP address there. And then IPv4 address there, the signal strength, you can see my signal. So all of that information, you can see the graphic processing unit. I have a GPU here on my system, video processing. There it is. All of that information you can see on the machine. All right, let me just switch to my slide. All right, guys, let me see if I can move to, where's my slide? I can't find my slide anymore. My slide. I thought I had somewhere here. I'm not sure if it's this one. Let me check. All right, I think I'm on the right one. The CPU, there we've looked at the CPU, the speed of the CPU. We know where you can check the speed of the CPU, the number of cores, number of threads, hyper threading, CPU hyper threading. All right, so this is the concept that I was talking about. I told you that each core there, that on that picture, it has a L1 cache inbuilt, as you can see, and then L2, and then if it's dual core, that means there's L3 cache outside of these cores, which they share, these two cores share the L3 cache, but they all have the L1 and L2 inbuilt inside the core, and then they're only sharing what? The L3. Does that concept make sense? So if the CPU if your CPU is only L1 and L2, then that means the L1 cache will be inside the core, and then the L2 is the one that will be outside. If it happens that's okay, some of the CPUs they have only L1 and L2 cache, so you find out that their L1 cache is the only one that's inside the core, and then the L2 is outside the core, right? But if you have if your CPU has L1 up to L3 cache, then that means L1 and L2 they are built inside the core, and then the L3 is outside. Sandile?
Mr. Moyo.
Sure.
Yeah, I'd like to ask. So inside the core, I see L1D and L1I. Is it I or L?
Yeah.
So why you saw the L1, is it divided in K2?
Yeah, the newer processors, the older one, they only have like the L1 and then the L2. So now they can the new ones, because they keep on trying to increase the size of the L1 caches, right? So now they have two, which is divided now, the L1D, the L11. So there are two now sharing trying to increase the capacity of the L1.
So what does the L1D stands for?
I don't know. I just think it's the naming convention for them. You find that the AMD they don't have like the naming convention. It just says L1 and then L1B, something like that.
Okay.
Unless if I'm missing something, but I just think it's the naming convention for that.
Okay.
So back in the day, the older ones they only had like the L1 and then the L2 and the L3. We didn't have like the separate L1 and L1D or L1I. So it was only the L1 cache. But because I say these are a cache like it's a temporary storage, right? And then they were designed to not have like more storage space or not more capacity. They have like the lower capacity. So now if it has two L1s, then that means it increases the capacity, of which now it helps your PC to process faster whatever things that you're working on at that moment. So that's the main reason for this. We said they're built inside the core, and then it's therefore easy access from the CPU.
Okay.
All right. Okay, system RAM, mass storage. So this is the concept that I was talking about. So we said on this first diagram at the top, right, where you see the processor package, if the CPU can't store all of that information on that first diagram there, right, on the L1 cache, L1D, L1I, and then L2, L3. So that means there's no space. It has failed to store all of that information. We are running a lot of applications at the same time. So meaning that it can't run all of those in that package. It moves to system RAM. And then from the system RAM, it fails again. Then it moves to mass storage. Mass storage, this is your hard drive, HDD, hard disk drive, or your SSD. And then they will support your CPU. But if all that fails, then you start to see the scrolling wheel. Does the concept make sense? What happens within or inside the CPU when the CPU is processing something?
Yes.
All right. So we're saying on the first diagram, if everything fails, right, it moves to system RAM, and then if it's not enough, it moves to mass storage. Right. All right. Let me see if I have. Okay, visual technology. A visual technology, this is the part whereby we know it supports virtual VMwares, and then visual technology, if it's activated on your CPU, you can, okay, let me start from here. By default, your computer, it can only run how many applications at a time? How many operating system at a time? How many
One at a
how many
time.
operating systems can your machine run at a time?
One at a
simultaneously.
time.
Only one operating system can run at a time, right? So this part of the virtual technology, it is a part, okay, back in the day, we also had something called a dual boot. Anyone who knows what a dual boot is for?
I know.
Anyone wants to try what a dual boot is? So a dual boot is a machine that is been installed like maybe 2 operating system or more than 2, right? So you have maybe Windows 10 and then Windows 7 on your machine. But the thing is, if there is no virtualization technology, only one application, only one operating system can run at a time, right? So with virtual technology, it allows us to create what we call the VMs, the VMware, right? Whereby you can load, like let's say you download a software from VMware and then install it on your machine. That will allow you to run 10 to 15 or even 10 or 2, 3 operating systems simultaneously in your machine. Right? So visual technology, it allows you to create an environment that will allow you to run more than one operating system simultaneously in your machine. So meaning that you can have Windows 10 running, you can have Linux running, you can have Ubuntu, you can have what you call any other operating system in your machine running simultaneously in your machine. Does that part make sense? So without virtual technology, we can only run maybe one operating system at a time. But yes, we can have dual boot machine. Dual boot means that sometimes if I want to run Windows 10, I can boot my machine from Windows 10, right? Or next time now I want to use Windows 7, I can boot or I can switch on my machine to boot from Windows 7. But those 2 operating systems, they cannot run simultaneously in my machine at the same time. That's the problem with dual boot, right? So they came up with a technology called virtual technology, which creates an environment for you to load more than one operating system, and then all of those operating systems can run simultaneously in your machine. So you can have 10 operating systems running at the same time in your machine. There's a concept called the guest, and then the other one called the host. So you have like the host maybe being your Windows 10, and then the other ones, they're running on top of Windows 10. So that's the main reason why we have virtual technology, to allow us to create an environment to run more than 10 machines in our 10 operating systems in our system. So you're going to hear the term called VMs, right? So these are the other, you find that the VM is just like the other computers, other systems that are running on top of your system, other operating systems running on top of your system. Does that part make sense? Does the concept make sense?
Yes.
So we said normally
Yes.
your machine can only run one operating system, right? In your machine. It can't run more than one. And then we said, point number 2 was, we said you can do what we call a dual boot, whereby your machine or your hard drive has 2 operating systems. But the problem with the dual boot, only one operating system can run at a time. If you want to run Windows 7, then you have to switch to Windows 7. If you want to move now to Windows 10, let's say you have dual boot, which is Windows 7 and Windows 10, you can now run Windows 10, and then if you want to run Windows 7, you switch to Windows 7, and then if you want to go back to Windows 10, you switch to Windows 10. So you can't run them simultaneously. They can't all run at the same time. And then we said the visual technology, it allowed us to create the VMs, or the environment that allows us to run more than one application or more than one operating system in that machine. That's why we have the VMs. You're going to hear people talk about the VM. So that's why the visual technology, it allows us to create an environment whereby the guest operating systems can rely on the hardware specs of your the host machine. We're going to do visualization. We're going to do the practical of this, right? So that I can do some demonstration. I'm not sure when, but I will do the demo of visualization so you understand what this is all about. And then we're going to look at, take a deep dive into Windows 10. How do we conduct support? I think Opake is going to run that. How to conduct support for Windows 10 users, right? So if you are working in an environment that is people that are using Windows 10, if what are the problems that the people usually face, and then how do we fix those problems? We're gonna talk. We're gonna save that. Sorry, the topic for that day will be visualization, right? We're going to name it, visualization. No, not visualization, sorry. We're going to call it troubleshooting, where so Obakeng is going to go through the problems that people face in a work environment. So those are things that we're going to go through. Okay, the visualization part of visual technology, I'm sure it makes sense now. Why do we have that technology? So you can see down here where, if you look at the diagram that I have, when it's written, where it's written virtual machine settings, you'll see where it says visualization engine, and then there's a part that says visualize Intel VT. So that technology, once it's activated, then it will allow you to run visualization machines. So I've seen most people when they're trying to run virtual machine, and then they strike because the application or the virtual machine it can't run on their machines. It's because they didn't activate the the Intel VTX. So that VTX, it has to be activated on BIOS. Once you activate it, then you'll be able to run other applications in your machine. So you have to go to BIOS and then enable that. Okay. Next, let me see what's next. Visual technology. And then the cooling system now, we have what we call the fan. So you see that on top of the fan, on top of the CPU, we apply what we call the thermal paste. So in this diagram, there is the socket at the bottom, right? We have looked at different types of sockets. We looked at the AMD socket. We looked at the Intel socket. So that's what, okay, socket. Okay, sorry guys. I think we can end today's class here. Anyone with questions, we're going to take it from here, and then I don't know when. But today we don't have class. You guys are going to go through your assignments and then try to complete your assignments, right? All right, guys. Any questions before I close? G4S and then depositor, guys. Are you struggling with any assignments? Rose, are you struggling with any assignments on the G4? Anyone who's under G4S here? Technical support level.
Under G4S
Okay, so tomorrow I'm saying we don't. Yeah, tomorrow we don't have class, right? No online class. So you're gonna take that time to go through the assignments, and then if you're struggling with any assignments, you can drop me a message, or Roshan or Adrian a message, and then we'll be able to help you with those assignments. So tomorrow we're going through our assignments.
Thank
right?
you, sir.
So, any questions with regards to today's session? Sandile?
So are we all going through our assignments or only the G4S?
Sandile, which group are you under?
System development.
System development.
Yeah.
When are you supposed to submit your assignments?
On the 12th.
On the 12th. Okay, I don't think you have class tomorrow, unless if Adrian says so that we have class tomorrow, right?
Okay.
All right. So, but for the G4S tech support and then the depositor tech support, Josias, you want to say something?
Yeah, Mr. Moyo.
Sure.
When must we submit our module 1 assignments?
Module 1, I think you were supposed to submit it on Monday. Now this week we're doing module 2, right?
Yeah, we started module 2 now.
Okay, so just make sure that today you submit. If not today, make sure to submit tomorrow, module 1.
So how must I submit? Must I come to Rambek or?
No, now I prefer you scan them to me, and then just keep the, you can use any application to scan them to us. And then we're gonna just go through the assignments and then see if you need to remediate anything there. And then yeah, we'll let you know. But just scan them to me. Use any application using your phone. You don't have to go to internet cafe. Just use your phone.
Okay. And then to you.
All right. Josias, are you answered? Right. Don't come to advanced assessment. Just scan them to us, and then we go through them, and then we'll tell you, okay, if you need to correct anything, then we'll let you know.
Okay.
All right.
Yeah,
Yeah.
you can use your email or submit.
Yeah, you can use my email. Just email to me. I'll drop the email in the group. I think Adrian or Roshan, they also drop their emails there. Make sure that you label your assignments, right? Make sure that you tell us, okay, who are you, so that we can be able to pick up to who exactly is. Also, write your names on the assignments at the top of your assignments so we know who it is.
Okay.
Yeah, Kidbone? Okay, no questions, right?
Yes.
All right. You can drop just do what we usually do here. You know the tradition. Just write your name and the group there, and then we're gonna use that as our report, as our register. I mean. So I'm done on my side. You can write your name, surname, group, and then you leave the meeting. It's fine.
Hey Melissa, is the class over?